In this part of our lesson, we're going to talk about rational equation applications. So now we're going to apply a word problem, an applied problem, to use a rational equation to solve it. So the idea here is we're going to create the rational equation that we need in order to solve the problem that we're given. Right now at our stage, we're only allowed one variable for our equation. Any other unknown quantities need to be written in terms of that one variable. So we're going to practice trying to choose only one variable and then trying to be able to write other unknowns in terms of that one variable based on what's given to us in the problem. A problem-solving strategy that hopefully will be helpful, it's something that I use a lot. You don't read the problem one time. You read it a bunch of times. I read it and I write on it. I circle quantities that I need. I circle important words. I underline. Read the problem until you feel comfortable with it. You should not expect to understand everything the first time you read it. A lot of students have this as a misconception. The teacher only read it once. I should only read it once and know exactly what I should do. No. The only reason we read it once is because we've had years of schooling on this. You haven't. We as teachers need to be modeling that for you. So we read it multiple times. I'm going to try to break it down for you when we get to a problem. If it's helpful, draw a picture or a diagram. Sometimes I use tables to organize the information. It makes things a little bit easier in my brain. And then you answer 3 questions. What am I looking for? Call that the variable you want. Most of the time I use X. Sometimes if we're talking about time, I might use T. Variable doesn't matter. As long as you can distinguish that variable from other numbers, you're good. What do you need in order to find the answer? And what do you already have? What is already given in the problem? What do I need in order to find the answer? This could be a special formula that we need to get an answer, and you'll see a little bit later what I mean by that. We'll talk about the formula that we need in these first few problems. And then form our equation, plug in our numbers, and solve for the unknown. And then we check our answer. We don't just check our answer in our equation, because what if this forming my equation, what if that is not the correct equation, but I do everything mathematically correct on it, then my answer is going to work in my equation. I need to make sure that my answer makes sense in the context of the problem. So this is an important one. Make sure your answer makes sense. If it doesn't make sense, something went wrong, likely up here with the forming of your equation. Okay, let's start out by talking about uniform distance problems. And this is not intended to scare you by any means, but these are the problems like the 2 trains going towards each other and they're going to collide. These are those kind of problems. But we're going to break it down. We're going to see if we can make sense of the pieces and be able to create an equation that we can solve for. Okay, so first up, we need the formula for distance. Do you know how to calculate distance? A lot of times, students yell this one out. Students yell this one out. D equals R times T. That is the formula for distance. But it's meaningless if you don't know what those variables stand for. So the D, it's distance. How do we calculate distance? We need to know how fast we're going, and we need to know how long we're traveling at that speed. So distance equals rate times time. Let's see how we can apply the distance equals rate times time formula in the context of a problem. So our first example. Alina can bike 30 miles in the same amount of time that it takes her brother Ben to bike 25 miles. If Alina bikes 2 miles per hour faster than Ben, find the biking speed of each sibling. We're going to read it again, and this time I'm going to mark it up. If you need to read it more than one time before you start marking it up, absolutely do that. Let's interact with it. What am I given in the problem? I know Alina can bike 30 miles. Ben can bike 25 miles. I know she does this in the same amount of time. And I'm also given Alina bikes 2 miles per hour faster than Ben. And I'm being asked to find the biking speed of each sibling. Not just one sibling, but both. Miles are distance. So Alina bikes 30 miles. Ben bikes 25 miles. Same amount of time. Even though I don't know the time, I don't really want to put anything here yet because I don't know what that same amount of time means. Let's go back to what we're looking for. What are we looking for? The biking speed of each sibling. I want that to be my variable somehow. My variable should be something about biking speed. So X, or if you're using a different letter, that's totally fine. The variable should be in this rate column. Alina bikes 2 miles per hour faster than Ben. So let's put some numbers in here and see if we can make sense. Suppose Ben bikes 10 miles per hour. So suppose Ben bikes 10 miles per hour. Then Alina, biking 2 miles per hour faster, would bike at 12 miles per hour. I don't know that the answer is 10. I'm just putting it in here to try to figure out this one phrase. If Alina bikes 2 miles per hour faster than Ben. Let's let Ben be X, and let's let Alina's rate 2 miles per hour faster. If Ben is 10, Alina is 12, 2 miles per hour faster. So we're going to add 2. Whatever Ben's is, we're going to add 2 to get Alina's. Okay? I'm going to erase my suppositions. I don't want them to influence our answer. I have 2 of the 3 columns that I need to create my distance equals rate times time equation. Well, and the other thing to mention too is that this is an equation, distance equals rate times time, distance equals rate times time. And then the second one for Ben is an equation, distance equals rate times time. But the problem is I don't have anything for time. Let's think for a second. What section are we working on? Rational equations. So I can change this multiplication problem, distance equals rate times time, into a division problem, time equals distance divided by rate. And this is important because of this whole notion, same amount of time. Same amount of time means the times are going to be equal. So let's form these pieces, time equals distance divided by rate, and put those in the last column. So distance over rate, distance over rate. Let's talk about the physics of this problem. For a cyclist, if we're traveling a farther distance in the same amount of time, we should be going faster. So it does make sense that the rate for Alina is faster than that of Ben's because she's going farther. Now that we have our time column completed using the distance equals rate times time formula in a different form, we now can use this last piece of information, the same amount of time. The same amount of time. Well, if time is the same, these are going to be equal times. And now I have a rational equation that I need to solve. So using the steps we did before, find the LCD, all of the first fraction denominator, look at the second denominator. Do I have an x? No, I need to include it. Multiply both sides of the equation by the LCD, and then we can cancel common factors. X plus 2's, the x's. Remember, when we cancel, we're always leaving behind a 1. And I'm going to come up here. On the left side, I have 30x. And on the right side, I have 25x plus 25x plus 2. I need to distribute the 25. 30x equals 25x plus 50. And now I can subtract 25x. So I get my x's on the same side. 5x equals 50. And I promise you this is complete and total coincidence that I guessed the correct answer of 10 miles per hour. X is 10 miles per hour. So this is Ben's speed. X is 10 miles per hour. How do I get Alina's speed? I go back up here. Ben is 10, so Alina has to be 10 plus 2. I promise, total coincidence. You try the helicopter problem,